Hi students and parents, welcome to Maths Classes 7-8 CBSE by GK Pillai. This is my first video on the chapter Tale of Three Intersecting Lines. The fundamentals or the basics of the chapter given in the new textbook from 2025-26 are fully covered in my present video. The textbook questions and some extra questions will be dealt in my next video on the chapter. The chapter is actually on various properties related to triangles. Subscribe to my channel and share my videos to your friends. Also tell your friends of classes 8 and 10th to view and subscribe my channels. You will find a simple definition of a triangle. Also the parts of the triangle are explained here. A triangle has 3 vertices, 3 sides and 3 angles. P, Q, R are the vertices. PQ, QR and PR are the sides. Angle QPR, angle PQR and angle PRQ or angles PQR are the 3 angles. The triangles come in various shapes and they are classified according to the sides as well as angles. Now the classification of triangles based on sides. The first one is the scalene triangle. Here this one is a scalene triangle. All the 3 sides are different in this case. Second one, the isosceles triangle. In this triangle 2 sides are equal. And equilateral triangle, all the 3 sides are equal. Now the next one, classification of triangles based on angles. The first one is acute angled, second one is obtuse angled, and the third one right angled. Right, acute angle means in an acute angled triangle, all the 3 angles are acute angles, less than 90 degrees. In this triangle, all the 3 will be less than 90 degrees. And the second one, obtuse angled triangle. An obtuse angled triangle has one obtuse angle more than 90 degrees. In this case, this angle will be more than 90 degrees. And the last one, right angled triangle, as you must be knowing, one of the angles will be 90 degrees. Your present textbook gives some importance to equilateral triangle. So let us understand more on equilateral triangle along with the other type of triangles. So here equilateral triangle, this is an equilateral triangle. A triangle in which all the 3 sides are of equal length is called an equilateral triangle. And in an equilateral triangle, all sides have the same length and each angle has a measure of 60 degrees. So if you consider this triangle, all the 3 sides are equal, all the 3 angles are equal, and these angles are equal to 60 degrees each. Isosceles triangle, a triangle in which 2 sides are of equal length is called an isosceles triangle. In an isosceles triangle, 2 sides have the same length. Angles opposite to the equal sides are equal. If this is considered as an isosceles triangle, these 2 sides are equal and the angles opposite to these 2 sides are equal. So angle Q will be equal to angle R. Third one is the right triangle. In a right triangle, one angle is a right angle. You can see in this triangle, only this angle will be 90 degrees. Here you will learn how to construct an equilateral triangle. The way it is given here, you don't have to confuse. This is the way it is given in your textbook. So I have also done it like this, but actually you will be doing this way only in the class. Now we have to draw an equilateral triangle of side 5 cm. Draw a line segment AB 5 cm. With A as center and 5 cm as radius, draw an arc. With B as center and again 5 cm as radius, draw another arc. the two arcs will intersect at a point and mark it as C. Now join AC and BC. ABC is the required triangle. Let me explain you how to construct a scalene triangle. A scalene triangle has all three sides different. This is the way it is shown in your textbook, the construction, but you can draw it this way. What we will do, this is the way it is explained. So you don't have to bother about that. You will be able to construct the triangle this way. So we are constructing a triangle, scalene triangle with sides 4 cm, 5 cm and 6 cm. Draw a line segment AB 4 cm. Now draw an arc of radius 5 cm with A as center, the second measurement. With A as center and taking 5 cm on the compass, draw an arc like this. Next, with B as center and 6 cm as radius, draw another arc, and the two arcs will intersect at the point C. Now you can join AC and BC. So ABC will be the required scalene triangle. I have explained before this how to draw the equilateral triangle as well as scalene triangle. So you must have understood one thing. For a triangle to exist, the arcs that we construct to get the third vertex must intersect. Otherwise, a triangle does not exist. Let me take an example. While constructing a triangle with side lengths 3 cm, 4 cm and 8 cm, you can see here I have drawn a line segment with 8 cm as the base, AB. Now with A as center and 3 cm as radius, an arc is cut. With B as center and 4 cm as radius, another arc is cut. These two arcs are not intersecting anywhere. These two arcs will go and cut on this straight line only. That means a triangle does not exist. Now, it is possible to determine whether a triangle exists without actually carrying out the construction. This part you will understand when you learn about triangle inequality. Triangle inequality. Let me start from here. A triangle is possible when sum of the lengths of any two sides is greater than the third side. I repeat, a triangle is possible when sum of the lengths of any two sides is greater than the third side. I am giving importance to this one because it's a very important statement. Even in your higher classes, this may be asked. Triangle inequality goes this way. When each length of a triangle is smaller than sum of the other two, the lengths satisfy the triangle inequality. When each length of a triangle is smaller than sum of the other two, the lengths satisfy the triangle inequality. Examples: 3, 4, 5. This satisfies the triangle inequality because 3 plus 4 is greater than 5, 4 plus 5 is greater than 3, and 3 plus 5 is greater than 4. So these measurements satisfy the triangle inequality, and hence a triangle is possible. But let me see this one. Here 10, 15 and 30. 10 plus 15 is not greater than 30, but 30 plus 15 is greater than 10, and 10 plus 30 is greater than 15. So it does not satisfy the triangle inequality, and hence a triangle cannot be constructed with these side lengths. Now, for a given set of lengths, you may get a fill in the blanks or an MCQ based on this statement. For a given set of lengths where a triangle does not exist, the longest side length will be less than the sum of the other two. Here the same measurement I am taking here, 30 is greater than 10 plus 15. 30 is the uh, 30 is the longest side. We have seen how to construct triangles when their side lengths are given. Now we will take up constructions where along with the side lengths angle measures are also given. Here we are having two types of triangles. In this case, two sides and the included angle is given. In this case, the two angles are given and the included side is also given. Let us see the first one. The measurements, you have to go according to the measurements given by your school. So according to this, draw a line segment AB 5 centimeter at the point A. With the help of your protractor, mark angle 45 degrees and the ray will go like this. With A as center and 6 centimeter as radius, cut an arc on this ray at the point C. Join BC, ABC will be the required triangle. Now the next one, construction of a triangle when two angles and the included side are given. Now let me see here. PQ is a line segment, 5.5 centimeter. Draw this. Then at the point P, with the help of your protractor, mark 45 degrees. The ray will go like this. At the point Q also, mark another angle 40 degrees and the ray will be going like this. Let the two rays meet at the point R. Now PQR will be the required triangle. We have already seen that triangles do not exist for all sets of side lengths. Only when the sum of any two sides of a triangle is greater than the third side, a triangle is possible. We have already learnt about the triangle inequality. Similarly, in the same fashion, triangles do not exist for every combination of two angles and their included side. Here there are three examples given here. If the two angles of a triangle are greater than or equal to a right angle, then from these diagrams you can see that a triangle is not possible. In the first case, two obtuse angles. So naturally these two rays will go in different directions. They won't intersect. In the second case, there are two right angles. In this case also, the two rays will go in different directions. In the upward direction, they will not intersect. And the third one is a right angle and the other one is an obtuse angle. So naturally these two lines also will not intersect and a triangle is not possible. This is a very important property of triangle, angle sum property of a triangle. In simple words, sum of the three angles of a triangle is 180 degrees. You may be asked to prove this. Then you will have to write the whole thing. It is given in the textbook also in the same way. So let us consider a triangle ABC. We have to find the angles A plus B plus C. As a construction, we will draw XY parallel to the base BC. Now, you have to remember the alternate interior angles when two lines are parallel. Here, since XY is parallel to BC, this angle XAB is equal to angle B. And again, YAC is equal to angle C, alternate interior angles. Now, let us write A plus B plus C. That is what we have to find. A will remain as it is, and instead of B we will write XAB, and instead of C we will write YAC. That comes to 180 degrees. Why? These three angles, this and this, these three angles form a straight angle because this is a straight line. So ultimately we are getting A plus B plus C to be equal to 180 degrees. So sum of the three angles in any triangle is 180 degrees. This result is called the angle sum property of triangles. This is another important property of a triangle, the exterior angle. This is the exterior angle. Actually, when you are extending this BC this way, this is an extension, and the angle between this extension and this side is known as the exterior angle, this angle. And there is a relation between this angle and these two angles. The angle formed between the extension of a side of a triangle and the other side is called the exterior angle of a triangle. So angle ACD is the exterior angle, and there is a relation between the exterior angle and the two interior angle. You will learn how to proceed. From angle sum property of a triangle, we have this angle plus this angle plus this angle to be equal to 180 degrees. These three angles make 180 degrees. Mark it as 1. Now, angle ACD plus angle ACB, they form a linear pair. So sum of these two angles is 180 degrees. So we will write angle ACD plus angle ACB equal to 180 degrees, linear pair. Mark it as 2. In 1 and 2, the right hand side is 180 degrees. So leaving aside this 180 degrees, we can equate this portion with this one. That's what we are doing here. Angle A plus B plus ACB equal to angle ACD plus angle ACB. Now what will happen? ACB and ACB from both the sides will cancel away. So ultimately you are getting angle A plus B equal to angle ACD. So our statement is proved. An exterior angle of a triangle is equal to sum of its interior opposite angles. This is the exterior angle. This angle is equal to this angle plus this angle. You may get many questions based on this one. We will be discussing the construction of an altitude of a triangle using ruler and set square as given in the textbook. There is another way of drawing an altitude to a triangle using the compass. If your class teacher teaches you that way, then you can follow that. Otherwise, this is also definitely okay. Here, we have taken an arbitrary triangle. ABC is the triangle. You are not able to see the base. A is the vertex. From A, we will draw an altitude or a perpendicular to the base BC. How we will do? We will take a ruler and keep it alongside the base, aligned to the base. Now you take the set square and move it here and there in such a way that the set square is touching the point A. You have to move alongside the ruler only. You can see here, it is aligning with the ruler. Move it in such a way that the set square is touching the point A. Now you can draw a straight line alongside the set square so that it touches BC. Now AD will be the altitude. In the second case, this is an obtuse angled triangle. In an obtuse angled triangle, two altitudes will be outside the triangle. Only one will be within the triangle. From B, the way I have explained here, or with the help of a compass, you can draw an altitude like this. But for the side BC, the altitude will be outside the triangle. For the side AB also, the altitude will be outside the triangle. Let us see this one. So CB is extended this way, and from A we have to draw a perpendicular or the altitude. Keep the ruler alongside BC, or you can say CB. It should come up to here. Now take the set square and move it in such a way that from here you take it this way and it should touch the point A. The set square should touch the point A when moving alongside the ruler. So whenever it touches A, draw a perpendicular or the altitude. Now the next one is a right triangle. Here you will understand one thing. As far as a right triangle is concerned, both these sides other than the hypotenuse, both are altitudes of the triangle only. AB is an altitude for this side and BC is an altitude for the side AB. This is the end of my present video. As already I said in the beginning, please subscribe to my channel and also press the like button so as to show that you like this video. Tell your friends also to watch my videos regularly.